If you remember vertex form, you remember that you flip that sign and you keep that sign, which means the vertex of this parabola would be positive 2, negative 2. So you just have to find the graph that matches that. And this parabola right here has a vertex at positive 2, negative 2. So A is the answer. To get slope-intercept form, you need the slope and the y-intercept. So the y-intercept is where it crosses the y-axis. So it means that B is positive 4. And we just need the slope. So we're going to find another good point on the graph. And it looks like right here is another good point. So now we just need to count the rise and the run. And it looks like it's down 3 units and to the right 1 unit. So that means it will be a negative 3 on top and a positive 1 on the bottom, which is the same thing as negative 3. So A matches up with that. To tell whether or not this ordered pair is a solution to that system, we're going to take x and we're going to take y and plug them into each equation. So we're going to have negative 2 plus negative 4, because that's what y is, and we're going to see if that equals negative 6. And negative 2 plus negative 4 is negative 6. So in the top equation, it works. We have to check the bottom equation. So that one, we have 2 multiplied by x, so multiplied by negative 2. And then we're going to subtract y, so it means we're going to subtract negative 4. And we need to see if that equals 11. So 2 times negative 2 is negative 4, and negative 4 is plus 4. Is negative 4 plus 4 11? Nope, it's 0. So that's not true. It did not work in the second one, and so our answer is no, because it has to work in both. Functions pass the vertical line test. So if I draw a vertical line anywhere on that graph, if it passes through a vertical line more than once, it fails. So the answer is no, this is not a function because it fails the vertical line test. When we look at number 5, we can draw a vertical line anywhere on this graph, and it will only cross a vertical line one time. So for that reason, yes, this graph is a function because it passes the vertical line test. To tell from a table if you have a function, you just have to look at all the x's, all the domains, and as long as none of those numbers repeat, it's a function. So this is yes. The x's or the domain don't repeat. And if you think about it, you can't be the same age 2 years in a row, so all those numbers have to be different. To evaluate the function, we're just going to take the 5 and plug it in for x. So we are going to write f of 5 equals negative 8 times 5 plus 6. And then we calculate that out. Negative 8 times 5 is negative 40, and negative 40 plus 6 is negative 34. Same thing for number 8. We're going to take the negative 4 and we're going to plug it in for x. So f of negative 4 equals negative 7 times negative 4, because that's where the x is, squared plus 10. So we have to follow PEMDAS, the order of operations, and exponents come before multiplying. So before we multiply the 7 and 4, the negative 7 and negative 4, we need to take care of the exponent on the negative 4. So negative 4 to the second power is positive 16. So now we can multiply negative 7 times 16, which is negative 112. And when you add 10 to that, you get negative 102. For number 9, we have a jet traveling 375 miles an hour. That's its speed. The distance is 968, and we want to write a function for the distance remaining on the trip t hours after takeoff. So distance as a function of time, d of t, will be how far our trip is. So at the beginning of our trip, before we haven't traveled anywhere, is 968. That distance gets smaller the closer and closer we get to our destination, and it depends on how fast we're going. So here's the speed, and it depends on how many hours we've been traveling. So that's it. Number 10 is very similar. It's going to start with d of t. You start with the distance for your trip, and that distance gets smaller depending on how fast you are flying and how many hours you have been in the air. The domain is all of the x's, so you got to put them in brackets and order them from low to high. And the range is all the y's. So inside brackets, we will list all of the y values from low to high, and that's it. Number 12, the parent function depends on the exponent, and since that exponent is 3, this is a cubic function. And the vertex, we only have a number inside the parentheses, and inside the parentheses, you always flip the sign, and it's always a horizontal move. So we're not going to move left 2 like -2 would make you think. We're going to move to the right 2. And there's no number on the outside, so it means it didn't move anywhere up or down. To simplify number 13, I'm going to put all of the like terms one on top of each other. So I'm going to start with all of the normal numbers, the coefficients, and there's no number on top, so it's a 1, and there's a 2 on the bottom. Next, I'm going to stack the a's up, a to the 6th and a to the 1st. All I'm doing is spreading these out so it's easier to read. B to the -2nds on top. We don't have any b's on the bottom. And then c to the 8th on top and c to the 16th on bottom. All right, now we can start simplifying. 1/2 does not simplify. That's as low as that fraction goes. So we will keep the 1 on top and keep the 2 on bottom. When we divide exponents, we subtract them. So 6 minus 1 is 5, so it's a to the 5th on top. This negative exponent means that we need to move the b to the bottom and make the exponent positive. And last, we have the c's. It'll be 8 minus 16. That's going to be c to the -8. However, we can't leave that c to the -8 on top. We also need to move that to the bottom and make it positive. So on the bottom, we'll have c to the +8. So that's it as far as how simple you can get your answer. You don't have to have the 1 in front, and that's it. So I spread out number 14 with all the like terms on top of each other, and now I'm going to go through and simplify. So for this one, 10 divided by 2 is 5. 5 on top of a 1. So you can write the 1 on bottom, but we don't have to. For the a's, 10 minus 1 is 9, so we have a to the 9th on top. That b to the -3 needs to move to the bottom and become positive. And we're going to have 2 minus 12, which is -10, but instead of leaving c to the -10 on top, we're going to put c to the +10 on bottom. The first step to solving number 15 is to distribute the -2. So we'll have -28 minus 14z equals -56. Next, we need to add 28 to both sides. So we have -14z equals -28. That's what that totals out to. And then we need to divide by -14 to get the z all by itself. And our final answer is z equals -28 divided by -14 is +2. So I distributed the negative 3 on number 16. I got negative 72 and plus 18x. So the next step is to add 72 to both sides. So we have 18x equals 144. Divide by 18, and we get x equals 8. To find the x-intercept, we're going to plug in 0 for y, which means that that crosses out, and we're going to solve 4x equals 24. When we solve that, we get x equals 6. Next, we're going to do the same thing, except for we're going to plug the 0 in for x. So 4 times 0 is going to cross that out, and we have to solve 8y equals 24. So when we solve for y, we get 3. So these are intercepts. We need ordered pairs for our answers. If x is 6, that was when y was 0. And if y is 3, we'll put that in the y place, and that was when x was 0. So that's your final answer. We just have to find the slope, and we have the formula right here. So I'm going to label x1, y1, x2, y2, and start plugging into the formula. So y2 is 3. We're going to subtract 1. x2 is negative 2, and we're going to subtract 4. So 3 minus 1 is 2. Negative 2 minus 4 is negative 6, and when we reduce that, we get negative 1 over 3. To graph this, the plane number is our y-intercept, which is positive 3. So I'm putting a dot on 3 on the y-axis, and if you notice, there's no x. It's really like this, 0x plus 3. So it means our slope is 0, and slopes that are 0 are horizontal lines. So right through 3, we have a horizontal line, and I am making it solid because it's less than or equal to. If it was just less than, we would make a dashed line. And less than means we shade everything lower than that line. Our y-intercept in number 20 is negative 1, so I'm putting a dot on negative 1. Our slope is 2 over 1, so we need to count up 2 and to the right 1 from that blue dot. So we're counting up 2, 1, 2, and to the right 1. Up 2, right 1. Up 2, right 1. We can even go down 2 and backwards 1. And when we connect those dots, we're done. Number 21 recommends solving by elimination because all the x's, all the y's, the equal signs, and the plane numbers are all lined up vertically. So we need to totally get rid of either the x's or the y's. If we were to add these equations together, 2x plus 2x would be 4x, and they would not go away. But if we subtract these two equations, 2x minus 2x will go away. So we're going to subtract everything. 2y minus 5y is negative 3y. 10 minus 16 is negative 6. So we'll divide both sides by negative 3, and we get y equals positive 2. So we take that y, and we plug it into either y. It doesn't matter which. I'll use the top equation, so we can solve for x. So it's 2x plus 2 times y, which we just got 2. Set it equal to 10. 2 times 2 is 4. And we just keep going till we solve for x. 2x equals 6. And x equals 3. So our answer here is 3 for x, comma, 2 for y. That's where those two lines cross. On number 22, we still want to use elimination because everything is nice and lined up. But what do we want to get rid of here? The x's or the y's? The y's will cancel out with the signs that they have, negative and a positive. So it means we can add these two equations together. So 1x plus 2x is 3x. Negative 3y plus 3y cancels out, and 10 plus 20 is 30. So x is going to equal 10. Once we solve for that, we can take it and plug it into either one of the x's. It doesn't matter which one. So we have 10 minus 3y equals 10. When I subtract 10 from both sides, I get negative 3y equals 0. And when I divide by negative 3, I get 0. So the ordered pair here is x, which is 10, comma, y, which is 0.